Okay, so now for problem number 10, we have here that we have a figure with two blocks. The mass is, one mass is 2 kilograms, other one is 3. They're connected by a light string, and it has a moment of inertia of 0.00400 and has a radius of 5 centimeters. The coefficient of friction for the tabletop is 0.300. The block is released from rest using energy methods. Find the speed of the upper block as it has moved 0.600 meters. Okay, so now to solve that, we first have to know that the net work here is equal to the change in kinetic energy, right? And now we start looking at what other works to look at, right? So we're gonna start looking at the weight force, right? Because this weight force is only doing the force on this block, right? Because the weight is gonna be going downward, and when the weight's gonna be going downward here, and it's perpendicular to this one. It's perpendicular to the displacement, so the work done there by the weight, the work done by the weight that's acting on this force is considered, right? And now the work of the friction right there, this too should be the total work, and it's negative, and it's only going to be acting on this one right here, right? Because there's friction. And now the tension force, you shouldn't have to consider any tension force, any work on the tension, because they cancel each other out, right? This one's going this way and this one's going up, this one's going that way, so they cancel each other out. Now the work of the weight force, right, should be equal to the negative change in potential energy. And knowing that, we have here the work of the non-conservative force now, right? So we use this, and we solve for the equation before, and we equal that to the change in kinetic energy plus the change in potential energy, which equals the change in K, which is actually the kinetic energy. So this one here is the kinetic energy. There. And we're going to use this equation to move on. Okay, now we move on, and now we have here, when I say the displacement of CS is when it's displaced by 0.6. So I changed this friction to negative mg because it's going down, and to the weight force, and that should be the same thing as the negative friction force. And these things are not unknown, we already know them. So now we have this, which is the representative of the mechanical energy. This is a mechanical energy of V of the M1, and then this is the mechanical energy of M2, and this here, it represents the rotational energy, and then we add it by the potential energy of mass 2. So we have the kinetic energy plus the potential energy found here, right? And that's basically what we have. And we have everything known, and if you solve it through, and what you were looking for is VF, and if you solve it through, it's very involved, the work, but once you plug in everything in, you should get around 1.48.